Okay, so just one word of caution when deciding your uncertainties for the IAs. Now, in the case in my previous video, we had a ruler and I put a piece of paper next to the ruler. Now, I've got all the time in the world. I can just look at the piece of paper, take my time, really looking close at this point and get as accurate a number as possible, okay? So in this case, I would be confident in saying, I can't remember the exact numbers, but it would be 7 centimeters plus minus half of the smallest increment. I'm confident that that would be my uncertainty, okay? Because I've got a lot of time to be able to look at it and read it. Now, there are a lot of situations where even though you're using an analog instrument or a digital instrument and you think, oh, I'll just follow the rules that Mr. Jones said in the previous video, it's not going to work like that. I'll give an example. Let's say you have a friend and your friend, who's got a very long arm, drops the ball onto the ground. Now you want to measure the time it takes for the ball to hit the ground. And what do you use? This is your phone, okay, with the screen, and your phone has a timer. And let's say you measure 0.37 of a second. Now, if you follow my instructions in the previous video, you say, aha, 0.37 seconds is the time it takes to hit the ground, and the smallest digit, because this is a digital instrument, would be this. Now, can we really say that you've measured the time to this precision? Okay? I don't think that's fair, because your reaction time, not only your eyes, but the reaction time of you pressing the button with your thumb or whatever finger it might be, is not really that accurate. The phone is, but you're not, okay? So the rules I mentioned in the previous video do apply, but you have to be honest with yourself, look at the situation and say, can I really measure it that accurately? And to be honest, with this case, you're stopping and starting. So you're making two measurements. You're making a measurement of when the ball starts moving and when the ball stops moving. So I'd say there's a lot of uncertainty there. The rule in this case, be conservative, be pessimistic. It's always okay to be more pessimistic in science. Just using my judgment here, I would say, okay, well, we'll keep the value. There's no reason to get rid of that. But what would my uncertainty be? Well, factor in my reaction times and my eyes. I'm going to be pessimistic and say 1/4 of a second. Now, you might say, well, my reactions are better than that, but it's always good to be pessimistic. So, in practice, when making your determination of what the uncertainty should be, use your judgment and be conservative, be pessimistic. Okay.